Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. How are you feeling today? I hope you enjoyed our previous lecture on costs. Costs are not the easiest part of microeconomics. I will give you that much. I cannot guarantee that it will be the most difficult part, because there is some more stuff that we still have to cover, and some of it is slightly more complicated than what we covered in our previous lecture. But certainly costs are not easy, and I would not be surprised if some of you are still confused about where the average cost curve is intersected by the marginal cost curve and what happens to the average fixed cost and the average variable cost. But the good thing is that we will be dealing with cost concepts all through the section on profit maximization and our discussion of market structures. So you will get a good chance to understand the concepts of cost. Now, we covered quite a lot of ground in our previous lecture on costs. We differentiated between fixed costs and variable costs, marginal costs, average costs, total costs. We drew all these curves. We then discriminated between short-run and long-run costs, etc., etc. Today, we will talk a little bit more about costs, but the greater part of today's lecture will be spent discussing revenue and profit maximization. Remember, all this discussion on costs and the discussion on revenue today would be sort of meaningless, not entirely meaningless, but would not have as much importance if it were not put in the context of profits. Remember that we introduced the theory of the firm and said that any particular firm wants to maximize the profit that it makes, the total profit that it makes. And we said that total profits are simply equal to total revenues minus total costs. And it is not possible to understand what happens to profits unless one understands what happens to revenues and what happens to costs and how are they behaving. So it's very important for us to fully understand cost concepts. And if you remember, we introduced one last part in yesterday's lecture, in our previous lecture, and that was when we talked about the relationship between short-run and long-run average costs. Yeah, this is where we will start today's lecture. Now, what I mentioned yesterday was simply that it is the aggregation of the short-run average costs which makes or brings about the long-run average cost curve. But the way it actually happens is a little bit more complicated. It's not just average cost curves being superimposed on one another and giving rise to one long-run average cost curve. It needs to be illustrated through the use of graphs. And therefore, let's go to the first graphs for today's lecture. Let's go to our graphs. Now let's take the case of a firm which has just one factory and faces a short-run average cost curve illustrated by SRAC1. Now as you can see, the SRAC1 cost curve has as its minimum point Q0, right? However, as we increase our output, the short-run average cost rises quite sharply. However, at this point or at some point Q1, the firm has the option, at least in the long run, to set up another factory, open another plant, and therefore it can move to another short-run average cost. However, note that this plant starts at a higher output level. That is, from the origin till point Q1, the cost of producing output is lower on the short-run average cost 1 curve. That is, with one factory, it is cheaper to produce output from 0 to Q1. However, from Q1 to Q2 or any outputs after Q1, it becomes cheaper to produce using two factories. So the second factory is perhaps a bigger one and therefore relies or needs a larger output in order to become cost efficient. By the same logic, the firm can consider opening another factory, a third factory, and this will give rise to the short run average cost 3, the SRAC 3. Again, from point Q2 onwards, it is cheaper to produce the output using the third factory or after having opened the third factory than it is to produce using just SRAC 1 and SRAC 2, right? And similarly, there is an infinite number of short run average cost curves that can be drawn. Note crucially, however, that the way we've drawn these curves is that initially the short run average cost curves fall a little bit. So they are obviously to the right of the previous average cost curve, but they are also below the previous one. And this is to capture economies of scale that accrue to the firm in the beginning as it increases its output. However, beyond SRAC 3, we see that the short run average cost curves have been drawn a little bit higher. And the reason for this is diseconomies of scale. Diseconomies of scale arise when the firm becomes so big that organizing it or managing it causes increasing costs in producing output. That is, it becomes difficult to produce more output unless the firm is willing to pay very high costs. And this is what is reflected when we draw the SRAC 4 and SRAC 5 higher than the SRAC 3 curve. Now, how does this combination of short run average cost curves give rise to the long run average cost curve, which is what we are interested in? Now, it makes sense that up to output Q1, the firm would probably only use the first plant, that is, would be on the short run average cost curve SRAC 1. However, if the firm decided to produce anywhere between Q1 and Q2, it would likely opt for the two factory option. That would likely want to have two factories. Likewise, between Q2 and Q3, the firm would be better off with three factories. Therefore, the long run average cost curve follows a wave shape. That is, it connects the short run average cost curves, but only those parts of it which are the least cost parts, least cost segments. So it will go up till Q1, then from Q1 to Q2, it will be SRAC 2, then from Q2 to Q3, it will be SRAC 3, and so on. In practice, however, it is usual to show the long run average cost curve as a smooth line instead of a wave. And when we draw a smooth line, it is usually drawn as a tangent to the short run average cost curves. This is known as the envelope curve. And the intuition behind this, or the logic behind this, is simple, that in reality you can draw many short run average cost curves, right? So the options available to the firm in terms of the number of plants that it can open and the quantity that each plant or each factory can produce is assumed to be infinite or very large. And therefore you can have very small or very closely spaced short run average cost curves. And if you go home and practice this by drawing very close and very small short run average cost curves, you will see that the wave will become very much like a smooth line which is tangential to all the short run average cost curves. And this is what is shown in the figure here. So that, my friends, concludes our discussion on costs, at least for the time being. Costs will re-emerge, as I said, when we discuss profit maximization and later in our discussion of profit maximization under different market structures, that is monopoly, oligopoly, etc., etc. However, let's now move to the second important part of the profit equation. That is, you remember profits were equal to revenues minus costs. So we've looked at costs, but we haven't looked at revenue. What is revenue? Revenue is simply the sales proceeds, the sales money that the firm earns. So when the firm sells its goods, it's simply the money that it gets in exchange of selling those goods. So for an ice cream seller, it's the payment that the consumer makes for a particular ice cream that would categorize as the firm's revenue. But different types of firms have different types of revenue and different types of income. But it's basically the inflows or the cash inflows for the firm which categorize as revenues. And we have to develop a good understanding of revenues if we are to understand how profit can be maximized, because profit is, after all, revenues minus costs. Now, the first thing about revenues that should immediately come to your mind is that the marginal, average, and total concepts that we developed in the context of costs should also apply to revenues, right? And they do. We have total revenue, we have marginal revenue, and we have average revenue. And the definitions are exactly the same as what we developed in the context of costs. Total revenue, and we've talked about it earlier as well in the lectures on elasticity, if you remember. Total revenue is simply price times quantity. So if a firm, let's say a firm which produces table tennis balls, do anybody of you like table tennis? I certainly do. A very nice game. Anyway, so if a firm produces table tennis balls and prices each ball at 5 rupees and sells 1,000 balls, let's say in a month or a quarter, let's say a month, then its monthly revenues will be simply 5 multiplied by 1,000. That is 5,000. That is total revenue in respect of the table tennis balls sold. What would be average revenue? Average revenue is simply total revenue divided by the quantity sold. Now, in this particular case, what is the total revenue? Total revenue is 5,000. What is the quantity sold? Quantity sold is 1,000. And therefore, average revenue is simply 5,000 divided by 1,000 is equal to 5. And you must be wondering, well, 5 is really the price. How come it's also the average revenue? Well, it is. And this is one of the principles that you should keep in your mind, that average revenue almost always equals to price. Average revenue will always be equal to price unless we are in the realm of a situation where a firm charges different prices to different consumers for the same product. So think of this table tennis firm. If it were selling, let's say, 400 table tennis balls at a price of rupees 5 and 500 table tennis balls at a price of rupees 4 and 100 table tennis balls at a price of rupees 6, then it would still be selling 1,000 table tennis balls, but its total revenues would not be 5,000. They would now be 4,600. And therefore, the average revenue that the firm would earn would be the total revenue, which is 4,600, divided by the total output or the total quantity sold, which is still 1,000, and which will give 4.6. And therefore, average revenue can be different from price only in the case when the firm charges different prices for its product to different customers. But for now, we will assume that price always equals average revenue. So keep that firmly fixed in your heads. The last concept of revenue that we need to know about is that of marginal revenue. And as you know, economists pay special attention to all these marginal things, marginal costs and marginal revenues. Very, very important. And we will see in a short while that they are key to understanding profit maximization. So what is marginal revenue? It is simply the change in total revenue divided by the change in quantity. So the addition to revenues of the addition of one output unit sold would be equal to marginal revenue. So if a firm has total revenues of 100 and it has sold 20 units of output, if it sells the 21st unit of output and earns 110 rupees in total, then the marginal revenue will be 10. 110 minus 100 divided by 21 minus 20. If there were 2 units that were sold in this case and the total revenue was, let's say, 130, then it would be 30 divided by 2. That is, the marginal revenue would be 15. So it's basically delta TR divided by delta Q. And you should all be very familiar with how these marginal things are derived from total concepts. Now, the thing that should interest us is to know how these revenue concepts or these total revenue, margin revenue or average revenue figures vary with output. Remember, we discussed how average, total and marginal costs varied over the output that the firm produced. For average cost, we saw that it was saucer shaped. For average fixed cost, we saw that it was a declining curve, and so on and so forth. So what's the relationship of revenues with output? Now, in order to understand this, we need to make the distinction between price-taking firms and price-making firms. And basically, we need to see how the relationship between revenues and output is characterized in both these situations, and they are actually quite different. Now, what does it mean when I say that a firm is a price-taking firm, and when I say that a firm is a price-making firm? When I say that a firm is a price-taking firm, I basically mean that the firm does not have the ability to influence the market price. So the market price is determined by a large number of buyers and sellers in the market, and the firm is just one small seller, and therefore it can't influence the market price which has been determined by the market. Therefore, for the first case, that is for the price taker case, the firm faces a constant price in the market, or the constant or a constant price for its sales. However, for the second case, which is the price maker case, we say that the firm influences the market price by how much it produces. So that is, if a firm, let's say, is the only producer in the market, right? And you might say, well, is that really possible? Well, sometimes it is. Look at WAPDA. It's the only one of its kind in power distribution. There is no other firm in Pakistan, or at least in northern Pakistan, which is involved in power distribution. Similarly, you have KESC in Karachi, which is the Karachi Electric Supply Corporation, and which is also the sole firm operating in that region. So it is possible for one firm industries, and we call them monopolies, to exist. However, it is not necessary for there to be only one firm in the market for that firm to be able to influence the market price. Even if there are 2 or 3 firms, but they are very, very large, then each of those firms' output decisions will impact the market price that is prevailing in the whole of the market. So price, in a way, becomes endogenous to the firm's output decisions. When I say endogenous, it means that prices are influenced by what firms do. They are not a given, or they are not an exogenous variable in this case. So we need to differentiate between these two categories. Let's illustrate this distinction through the use of some tables and graphs. Now let's start with the price-taking firm, and let's begin by analyzing what happens to average revenue if the firm sells or decides to sell more output. Now, if the firm is a price taker, it means that it is a small firm relative to the market, and therefore price is determined by the intersection of the market demand and supply curves. At this price, which is shown in this diagram as 5, the firm can sell any quantity. It can sell 200 units, it can sell 400 units, it can sell 600 units, but this will not be big enough to affect the price of 5, which has been determined by a large number of buyers and sellers. And as you can see, the units in the market curves are in millions, whereas the units for the firm are in hundreds and thousands. So there is a big difference. But insofar as the firm is concerned, the main implication of this is that the price curve or the price line is horizontal. That is, it is given at 5. And the firm can choose any output that it wishes to, or it can supply any output at that given price. Now the average revenue, if you remember, was seen to be the same thing as price. So the implication for average revenue in this case is that it is also a straight line. Marginal revenue is simply, as you remember, the addition to total revenues of selling each additional output, right? But by selling each additional output, the firm merely earns rupees 5. Therefore, the marginal revenue in this case will also be 5 rupees. That is, it will be equal to average revenue. Now, what happens to total revenue? Total revenue is average revenue times quantity. Now, since average revenue is price, total revenue is equal to price times quantity. And this can be seen as the area under the demand curve or the average revenue curve at each given output. So if the firm decided to produce, let's say, 400 units, then the area up till 400 under the demand or average revenue curve would be 400 multiplied by 5. That is 2000. If the firm decided to produce 800 units, then the area under the curve or under the demand curve or average revenue curve would be 800 times 5, which is equal to 4000. Now this can be plotted on a graph with total revenue on the vertical axis and quantity on the horizontal axis. So when the firm produces 400 units, the total revenue is 2000. When the firm produces 800 units, total revenue is 4000. And as you can see, the total revenue graph plots as a straight line through the origin. Now, one important point that you might have noted while I was talking in that slide was that I referred to the average revenue curve as the demand curve. And some of you might be wondering why I did that. Well, as I said earlier, the average revenue in the analysis that we are doing is always assumed equal to price, right? And once we are given that, we know that price, the relationship between price and output in a price output graph is captured by a demand curve. Therefore, the average revenue curve, given that the average revenue is equal to price, becomes equal to the demand curve. So this is the second principle or second important point that you should keep in your minds. That from a firm's point of view, the average revenue curve or the average revenue line is equal to the demand curve that the firm faces. Now the firm that we just talked about was a classic example of a price-taking firm which faced a horizontal demand curve. That is, it faced an infinite demand for however much product or however much quantity of that particular product it could produce, right? But because it was small, it would only produce a quantity which was small enough not to impact the overall market. But what happens when you have a price-making firm or a firm which influences prices by deciding to produce more or less? That is, it influences the market price. Let's illustrate what happens to marginal, average, and total revenue in this particular case. Let's go to our slide. Now let's say that we have just one firm operating in the market. And let's say this is the market for ships. Samundri jahaz, jise bahut bade jahaz. So there is just one firm involved in manufacturing these huge ships. Now the quantity, price, total revenue and marginal revenue figures for such a firm are shown in the table given. That is, when the firm produces one ship, the price that it can charge is rupees 8 crore. When it produces two ships, the price falls to rupees 7. When it produces the third ship, the price falls to rupees 6. Similarly, total revenue is simply the revenue that it makes, that is the average revenue times quantity. That is 8 times 1 gives 8, 7 times 2 gives 14, 6 times 3 gives 18. And the marginal revenue is simply the difference in total revenue. So marginal revenue is 6, which is the difference between 14 and 8, and it is 4, which is the difference between 18 and 14, and so on. Now, when we draw the market demand and supply curves for this industry, we see that this is essentially the demand and supply curves for the firm. So as you can see, if the firm increases its supply, in this case, the price falls from P1 to P2, right? So in other words, the firm cannot sell more units or more ships without reducing its price. This means that price, which is equal to average revenue, will fall with quantity. As the firm produces more and more ships, that is, as it moves further out from Q1 to Q2 to Q3, a downward sloping demand curve for the firm will emerge. Now, when we discuss marginal revenue, it's a little bit more tricky, and we'll have to refer to the table for this. Now, as you can see, if the quantity is to be increased in this table, that is, if the firm wants to increase the number of ships that it wants to sell, then it must reduce its price, right? Because the firm, in this case, is a price maker. It affects the price prevailing in the market because it increases its supply. But this means that the firm will have to lower the price for all the units, not just the additional unit that it wants to sell, right? Now let's illustrate this through the table. When the price is 7 crores, 2 ships are sold. Now if the firm wants to sell one more, that is, if it wants to sell 3 ships, it will have to lower the price to rupees 6. So it gains rupees 6 from the sale of the third ship, but note that it loses rupees 2 by having to reduce its price for the first 2 ships that it otherwise could have sold for rupees 7. Therefore, marginal revenue is equal to the gain in revenue because of the third ship, that is 6, minus the loss in revenue because of the fall in price of the first 2 units, that is minus 2, and this gives 4. And this is the extra revenue gained by the firm when it decides to sell the third unit. Now, as you can see, it is the balance of the gain in revenue and the loss in revenue which determines whether marginal revenue will be positive or negative. Now, marginal revenue has been plotted in the graph here, as you can see. Beyond point X, that is, in moving from 4 ships to 5 ships, the marginal revenue for the firm becomes negative. Now, what is the implication for this in terms of elasticity? Now, if you remember, we defined that a term is in its elastic region if the total revenue to the firm increases when the price of the output is decreased. So in this case, you can see that up till point X, the demand curve will be elastic. At point X, when the marginal revenue is 0, that is, a fall in price does not cause an increase or a decrease in total revenue. We have unit elasticity, and then to the right of point X, the demand curve would be inelastic. Now, the same information can be plotted in a total revenue graph, and as you can see here, you have a concave function that plots as total revenue. This is directly from the table. Now, the topmost point of the total revenue curve is where elasticity is equal to 1. Remember that marginal revenue is simply the slope of the total revenue curve, just as we said that marginal cost is the slope of the total cost curve. So when marginal revenue is equal to 0, which happens at point X, that is between 4 and 5, total revenue's slope, the slope of the total revenue function, should be equal to 0. And as you can see, this is exactly what happens. The total revenue curve turns or has its turning point between 4 and 5 ships. And then similarly towards the left of this point, you have elastic demand, and to the right of this point, you have inelastic demand. So, my friends, you saw there that the implications for the relationship between average, total, and marginal revenue with quantity are major for what assumption we make about the nature of the firm, whether the firm is a price taker or whether the firm is a price maker, has serious implications for such relationships. Now, we've only discussed the two polar cases today. That is the case where the firm is very small and that it cannot at all impact prices. And we've seen the other case in which the firm was the sole producer, the shipmaker in the market. So the firm itself was the market. However, there are intermediate categories as well, and we will discuss them when we discuss market structures. For now, we've concluded our discussion on revenues. And this enables us to stab into a discussion of profits. And we've been longing to do this for a long time. So finally, we have the chance. Now, firms are interested in maximizing profits. And throughout this course, I've defined profits as the difference between revenues and costs. So it's revenues minus costs. Total profits are equal to total revenues minus total costs. But the way economists define profits is sometimes a little bit funny, because they say that when a firm earns zero profit, that is when total revenue is equal to total cost, economists call that zero profit normal profit. And the argument behind that is that the total cost figure in this particular case, that is when it is equal to total revenue, it already includes the normal profit that the owners of the firm are making for themselves. That is the minimum profit that the owners of the firm need in order to remain in the business. Let me clarify this point a little bit, because this is an important point. What are costs? Costs are basically the payments that you have to make for the usage of the factors of production. And what are the factors of production? You have land. So the cost of land is rent, or the opportunity cost of land. That is, if you own the land yourself, then the opportunity cost, that is the value at which you could have rented the land, that is your cost. Then you have capital, and then capital which includes machinery, etc. You know, capital depreciates, so that's the cost of that. Then you have labor, and the cost of labor is wages. You have to pay wages to laborers. But there was also this fourth factor of production that we identified, which was entrepreneurship, which was the organization of the firm. The people who manage the firm are the entrepreneurs or owners of the firm. And they have to be paid as well. There is a cost of using that factor, of that economic factor as well. And that cost is called normal profit, or the return on equity, the required return on equity. And when economists say that total revenues are equal to total cost, they assume that the total costs already include that minimum required profit that the entrepreneurs need to stay in the business. Therefore, when profits as defined by revenues minus costs are zero, that is equivalent to normal profits. Whereas when revenues minus costs becomes a positive figure, that is described by economists as supernormal profits. That is profits in addition to normal profits. Now that enables us to come to the question of how firms try to maximize profits. And there are basically two approaches to studying this particular question. We can use total revenue and total cost curves to come up with an idea of total profit, or we can use marginal and average cost curves and marginal and average revenue curves in order to arrive at the profit maximization, profit maximizing output that the firm must produce. Now, what are the differences between these two approaches? we will illustrate shortly. But let me point out at the outset that the first approach is very simple, because total profits are simply total revenues minus total cost, and therefore you just see what total revenues are and total costs are, and you see where this difference is maximized. The second approach is not so simple, but it is far more useful, and I will illustrate the two approaches here, but from now on, after this, we will be using the second approach, which is the marginal and average cost and revenue curves approach to understanding how firms maximize profits. Let me also tell you about the two assumptions that we will be making in this. We will first of all assume that the firm is a price maker. We do not want to get into the discussion as to whether there is only one firm in the market or two or three. All we are saying is that the firm's supply decisions affect the market price. So we will take that assumption and we will take the demand curve as downward sloping. That is, the average revenue curve will be downward sloping. The second assumption that we will make is that the firm is operating in the short run. We will look at long run equilibrium and long run profit maximization approaches when we discuss the different market structures in more detail. But right now we will focus on a price making firm operating in the short run. Let's illustrate through a series of slides. Now first we look at the total cost and revenue curves approach to profit maximization. Now in order to draw the total revenue and cost curves, we need to get some figures for these total revenues and costs. And so keeping the typical shape of the total revenue curve and the total cost curves in our mind, remember that the total revenue curve is a concave function which goes up and then turns around and then falls, whereas the total cost curve is an upward sloping curve but has an inflection point in the middle. Now these figures in the table shown here are consistent with those shapes of the total revenue and total cost curves. Now as you can see, when 1 unit of output is produced, total revenue is 8, total cost is 10, and therefore total profit is 8 minus 10 is equal to minus 2. And note here that we are talking about supernormal profits. Then at quantity 3, the total revenue is 18 and total costs are 14 and total profits are 4. So from the table it is obvious that the maximum profit is obtained when the firm produces 3 units of output. Now let's see how this translates graphically. When we draw a graph, we find that the total cost and the total revenue curves are following the typical shape, right? The total revenue curve first rises, then falls, and the total cost curve rises with a point of inflection in the middle. Now, as you can see, the profit the total profit is merely the vertical distance between the total revenue and the total cost curves at any point, that is at any level of output. So when output is 3, the total profit is simply, 18 minus 14, that is equal to 4. And this is exactly what we obtained from the table. Now, if you plot the total profit figures that were shown in the table on this graph, you will find that it plots again like a total revenue curve, that it goes up and then goes down, and therefore you can trace out the maximum point that the total profit line will reach, and that also happens at point 3, and that is equal to 4. So the three approaches are consistent. The tabular approach, the drawing of the total revenue and total cost curve, or the drawing of the total profit curve. Now that's the way in which a firm uses the total cost and total revenue curves to decide at the profit maximizing level of output. And we saw that that level was 3 in our example, and that the maximum profit was 4. There was nothing complicated about it, very simple. Now the other approach, which is the marginal and average cost and revenue curves approach, is a little bit complicated. But once you become familiar with it, it becomes very simple. There are 2 steps to profit maximization using the marginal and average cost curves approach. The first step is that the profit is maximized at that quantity where marginal revenue is equal to marginal cost. So the first thing that you should do is draw the marginal revenue and marginal cost curves, see where they intersect, and that is the point at which the firm should produce if it wants to maximize profits. So that's rule number one. Once that quantity or that Q star, the optimal or the profit maximizing quantity has been identified, you can then look at the average revenue and average cost curves to see what is the area under the graphs, under the average revenue curve at that optimal or the profit maximizing quantity. And that will give you a measure of the size of the profit. So in the first step, you determine at what quantity to produce. That will give you the maximum profit. And in the second step, using the average curves, you see what the size of that maximum profit is. Let's illustrate this through the use of some examples. Now, let's first introduce some data that we can play around with. And let's take this hypothetical set in which you have quantity in the first column, price which is equal to average revenue in the second column, and you remember that when you draw this price variable on the PQ graph, you will get the demand curve. And then in the third column you have total revenue, in the fourth column you have marginal revenue, in the fifth column you have total costs, then average costs, marginal costs, total profits and average profits. Average profits, remember, is simply total profits divided by quantity Q. Now, if you plot this, some of this information on a graph, in fact, if you just take the marginal cost and marginal revenue curves or figures and draw them on a graph, you will get the graph shown. The marginal cost curve, as you can see, and consistent with what we have studied, first falls and then rises. Whereas the marginal revenue line is a straight line downward sloping which intersects the x-axis at the same point, yes, between 4 and 5. Now, what happens at the point of intersection? The point of intersection is E, and this happens when the quantity is Q star, which is equal to 3. Now, the question that might come to your mind is, why should the profit be maximized when marginal revenue is equal to marginal cost? Now, the answer to that question lies in studying what would happen when marginal revenue is not equal to marginal cost. So now look at this graph and pay attention to what I am saying. When marginal revenue is less than marginal cost, each additional or marginal unit adds to costs more than it does to revenues. Okay? So when you produce an extra unit, it raises your costs more than it raises your revenues. Therefore, it makes sense to not produce this additional unit and in fact cut down on your production. Okay? So when you are to the right of point E, you would want to come back towards point E. On the other hand, when marginal revenue is greater than marginal cost, that is when you are to the left of point E, then each additional or marginal unit adds more to revenues than it does to costs. Remember that marginal revenue and marginal costs are the marginal additions to total revenue and total costs. So in this case, the additional unit will add to your revenues more than what it adds to your costs. And therefore, it would make sense to increase your output and therefore produce this extra unit and move towards point E. So in either case, the optimal quantity will be obtained when Q star is reached, that is when marginal cost is exactly equal to marginal revenue. Now I hope that clarified to you a little bit why the profit maximizing output occurs at the intersection point of the marginal revenue and marginal cost curves. But I remember that when I was a student, I always used to get confused about this issue. And I used to wonder, how is it possible for profit to be maximized when the additional unit or the last unit that you have sold gives you no profit at all, right? When marginal revenue is equal to marginal cost, that means basically the additional revenue that you are getting is equal to the additional cost, and you are not making any profit on the last unit that you sell. And therefore, how does the profit become maximum at this point? I think the answer to that question I have found now. And the answer is that because marginal revenue and marginal costs are additions to some total, when the total profit, that is in this case, cannot be increased upon, that will happen only when the difference between marginal revenue and marginal cost is zero. If you could add to the profit, then the difference would be positive. If the profit could fall or were to fall, then the difference would be negative. But if you were already at a maximum, that is the point where you would not be able to add to the profit anymore. Now think of this in the context of climbing a hill. If you are climbing a hill and you reach the top of the hill, can you climb any more? No. You'll say that you are already at the top of the hill, and therefore that's the maximum point that you can reach. It's very similar for total profits. Once you reach the top of the total profit curve, you cannot go any higher, and therefore you will not be able to increase your profit by producing the marginal unit. And that is exactly the point where marginal revenue equals marginal cost. So I hope that example helps clarify what I was trying to explain earlier to you. That is the intuition behind why marginal revenue equals marginal cost gives you the profit maximizing output. Let's go back to our slide to see what the size of this output or the size of this maximized profit will be. Now, in order to understand what the size of the profit will be, we need to draw the average revenue and the average cost curves on the graph that we have already drawn. Now, as you can see, we first choose the output level that has been suggested by the intersection of the marginal cost and marginal revenue curves, and that happens at Q star, which is 3. Then we rise vertically and see where the vertical intersection of this output will be with the average revenue or demand curve. That is at point L. And then we see what the area OKLQ star will be. This, my friends, will be the total revenue that the firm will make. The area under the average revenue curve will be the total revenue that the firm will make. It will sell OQ star units of output, and the price will be 6 crore rupees. Okay? Then, if you look at the rectangle OFTQ star, that gives you the total cost that the firm will incur in producing OQ star units. How is that? That is simply because point T is the point where you have the intersection with the average cost curve. Okay? And all the area below the average cost curve and between Q star units of output is the total cost that the firm pays in order to produce Q star units of output. So OFTQ star gives you the total cost that the firm is paying. And therefore KFTL is the difference between the total revenues and the total costs, and this gives you the total profit. And in this case, this can just be calculated as 3 multiplied by the difference between the average revenue and the average cost, which is 1.33. Now, one small point, and that is that the vertical distance LT or KF gives you the average profit. So 1.33 in this case gives you the average profit, because that is simply the difference between average revenue and average cost. Note crucially that we are not using the MR and MC curves in the calculation of the size of the profit. We use the MR and MC curves to determine what output the firm would produce in order to maximize profits. Now we are only using the average revenue, that is the demand curve, and the average cost curves to determine the size of the profit. Now what we've discussed is basically the essence of profit maximization, especially in the context of a price-making firm. But we need to introduce some qualifications in order to nuance what we've studied a little bit. And what are those qualifications? The first is that we've basically discussed all this in the context of the short run. What would happen in the long run? How would profits be maximized in the long run? Well, the answer is very simple. If the marginal and average revenue curves remain the same for the firm in the long run, then the profit maximizing output will simply be obtained at the point where the marginal revenue curve intersects the long run marginal cost curve. So the long run marginal cost curve has replaced the short run marginal cost curve. That is the only difference. The second qualification that we need to make is about losses. The example that we just saw had only the case where the firm was making profits. But could it be possible that a firm is faced with a situation, at least in the short run, where it can't make a profit at any level of output? It is possible. Think of it graphically. When would this happen, that the firm cannot ever make a profit? If you think about it, that would happen when the average cost curve is always above the average revenue curve. You remember that profit or average profit is the difference between average revenue and average cost. So if average cost is always greater than average revenue, the firm will never be able to make a profit. And this point, if you still use the marginal cost and marginal revenue curves to arrive at the profit maximizing output, then you should more logically call that the loss minimizing output. That will not be the profit maximizing output, that will be the loss minimizing output. Let's illustrate this through a simple slide. Now as you can see here, at Q star, you have the firm making a loss which would be AC minus AR, that's the average loss that the firm is making, and then when you multiply it with Q star, you get the shaded area which is equal to the loss. At any other point than Q star, and remember that Q star is the point where MC and MR are intersecting, at any other point you will notice that the loss increases in size, does not fall. So Q star is indeed the loss minimizing output for the firm in such an unfortunate situation. Now my friends, I would have discussed two more qualifications, but I don't think we have time for this today. So we'll discuss it in our next lecture. This then brings us to the end of today's lecture. If you notice, we've covered a lot of ground today. We started by discussing the relationship between long run and short run average costs. Then we developed different revenue concepts, total, average and marginal revenue. We saw how these revenues changed with output for a price-taking firm and a price-making firm. And then we saw how profits were maximized using these revenue and cost intuitions that we have grasped. We gave two approaches to profit maximization. One was the total curves approach, and the other was the marginal and average curves approach. And finally, we were discussing some qualifications when we came to the end of our time limit for today. So till our next lecture, it will have to be Khuda Hafiz and Assalamu Alaikum.